Hello everyone. Today we're doing geometry. This is gonna be for grade 8 and for grade 9. If you're new to the channel, please subscribe, yes, and share and like the video and comment. Let us know what you think. We're gonna be covering basic geometry principles and rules for grade 8 and grade 9. It's a bit of revision because of you must have done some things from grade 7. So firstly, what we're going to do in geometry, I hope you can see what I'm doing here. Firstly, you need to know your angles. Number 2, you need to know the rules of calculating angles on what? Straight lines. You need to know all of this off by heart. And number 3, you need to know how to calculate angles on parallel lines. And number 4, we're going to do geometry in 2D shapes. In 2D shapes, we're going to go a bit deeper. We're going to be learning about triangles, kinds of triangles, how to calculate angles in triangles and all of that. And we're going to do quadrilaterals. Quadrilaterals are shapes that have 4 sides or 4 angles. We talk about parallelograms, your rectangle, your square, and all of that. So then we deal with congruency also and similarities. So these are very important topics that you need to know under geometry. So some of you must have done certain topics here, but we need to make sure that you are covered with every bit of it. So let's start with angles. Firstly, how many angles do we have? I think we have how many? We have 6. 6 kinds of angles. We've got acute angle. Acute angle is any angle that is less than 90 degrees. So less than 90 degrees. So anything 59 is an acute angle, 59 degrees and all of that. Remember, degrees are measured with this sign to show that we're measuring angles. So if they ask you what is an acute angle, it's an angle that is less than 90 degrees. Then we have got a right angle. A right angle is an angle that is equal to how much? 90 degrees. So it's actually a right angle. It's where this line and this line are perpendicular. The perpendicular lines, they form a right angle. A right angle is equal to how much? 90 degrees. Then we've got an obtuse angle. Obtuse angle is greater than 90 degrees, more than 90 degrees. So usually if we draw it anything less than 90 like that, something more than 90, it will be something like that. So more than 90 degrees. I hope you can see what I'm doing. I'm trying to summarize everything as quick as possible. Then what else do we have? We've got a straight line. A straight line angle. A straight line angle is an angle that is equal to how much? 180 degrees. We're gonna be using this one a lot of times, so you better know it now. So an angle here, if you've got your protractor, you're gonna see that it's actually half a circle. So it's how much? It's 180 degrees. So we call it a straight line. And then we've got what? A reflex angle. What is a reflex angle? A reflex angle is more than 90 but less than 360. 360. So if I were to write it, it's an any angle. Can I write it in terms of x? Let x represent a particular angle. The angle must be what? In between 360 and 90. So it's greater than 90, but it's less than 360. So that's your reflex angle. A reflex angle, this one inside is an acute angle, and that one outside there will be your reflex angle. I hope you can see it right there. So 1, 2, 3, 4, 5, 6. We call it a revolution. This is how much? Equals to how much? 360 degrees. Is when you a full circle. Now we've got a 360 there. So you need to know The shape, you need to know the definition, you need to know the rule. Sometimes they can give you this and say define it, or they say give an example of a reflex angle. So you have to know how it look like, or you need to define it. So there you go, your 6 kinds of angles. Let's go on. So we're going to number 2. Done. We're on number 2 now, straight lines. So when we're dealing with straight lines, we have how many rules? It's not a lot, but I'm going to be quick. So I'm going to do a proper video where we are dealing with them slowly, but I just want to summarize to everything on geometry so that we are on the same path. Even if you forgot some of your rules, we can answer the questions. There are questions that I want us to do, and we need to move. So firstly, on straight lines, we have how many rules? I think we have 4. We have 4. If I'm missing one, you can just let me know there, and then we're gonna add it. So we've got complementary angles. Complementary angles. What do you know about complementary angles? They add up to how much? 90 degrees. Complementary angles add up to 90 degrees. So we spoke about a right angle. A right angle is the angle here. So this angle is how much? Once you see something like this, they don't even have to tell you. Automatically, you need to know that this is how much? 90 degrees. So let's say this point here, it's A, and this whole angle is 90. But let's say, supposedly, they cut this angle into 2, and let's call this one angle 1, A1, and angle A2. So according to this rule, angle A1 plus angle A2 must give us how much? 90 degrees. So when I add these 2 angles, I must get 90 degrees because of they form a right angle right there. So if they tell you that this angle is 60 degrees, angle A2 is 60 degrees, and they say find the other angle, what are you going to do? So you're going to say, okay, in the place of A2, I'm going to say I'm looking for A1. Sorry, angle. Remember, the symbol for angle is like that. So A2 is how much? 30 degrees. So if they gave me A2 as 30 degrees, I know that these 2 angles must give me 180. So your rule will be, so these angles are next to each other, so you need to start with this word adjacent angles. That's the symbol for angles, equals to 90 degrees. Sorry, adjacent, complementary. You need to put that word. Complementary. Adjacent complementary angles are up to 90 degrees. So we're looking for A1. So if you're looking for A1, we're going to take 30 degrees to the other side. We've formed an equation, can you see, based on the rule. So 90 minus 30. So this angle becomes what? 60. So this angle is 60 and that angle is 30. Can you see? So we have found this missing angle based on the given angle and the rule that we had been given. Let's go on quickly. We go to angles on a straight line. So if they give you something like this, we know that angles on a straight line add up to how much? 180. So if they say they cut this 2 angle into 2, let's call it B maybe. This is B1, this is B2. So according to what we said, even when we were defining types of angles, this angle B1 and angle B2 must give us how much? 180 degrees. Can you all see there? So this means if they give us the one angle and they say find the other angle, based on this rule, we can find this. We call this supplementary angles. We find the supplementary angles add up to how much? 180 degrees. So when you add supplementary angles or angles on a straight line, they must give you 180. So let's say, for argument's sake, this one, we can see it's an obtuse angle. It has to be more than 90. You can all see that one. I mean, it's obvious. So they say, okay, the question says, find B1. They gave us B2, this, find B1. So what are we going to do? In the place of B2, I'm going to substitute 100 degrees. And I've got B1 right there, and 180 there. So if I'm looking for this one, obviously solve for x. We're going to transpose this one to the other side. It's going to change sign. So B1 equals to 180 minus this. Then we're left with 80. So B1 is actually 80 degrees. So remember, when we're dealing with geometry, every statement, your statement is your calculation or where you formulate your equation, it must go hand in hand with what? With a reason. If you don't have a reason, you lose a mark. So you give your statement, you give your calculation, and you give your reason. The reason for this one is what? Adjacent angles on a straight line. Add up to how much? 180 degrees. So your teacher won't penalize you if you just write this. Adjacent, can you see that there? Adjacent angles on straight line equals to 180 degrees. So if you want to make it short, you just write that one. But if you're not lazy, you can write it all of it like that. And you get 4 marks. But you need to give a reason for every reason. And the word adjacent means what? The angles that are next to each other. Can you see these two angles are adjacent to each other? We are not comparing this angle to another angle that is far-fetched. Can you all see? So let's continue. Number 3. The easiest one. I mean, this one everybody knows it. Opposite angles are equal. I hope you can see this handwriting. It's very beautiful, very beautiful. Yes, what do you know about vertically opposite angles? There's a Y there missing. Vertically opposite angles are equal. So let's say we've got lines there that are cutting each other like that. So this angle here will be exactly the same as that angle there. You don't even have to calculate. They are exactly the same, they are identical. The angles that are opposite, that are facing each other are equal. And that angle and that angle. Can you see I'm making the same symbol to show the ones that are the same? These two are the same, these two are the same. Meaning, if they give you, I'm just trying to use simple examples so that we understand. If they say, find the value of the angle here, you're going to look at the one that is facing it and you say, okay, x will be 80 degrees also because of vertically opposite angles are the same. Y will be how much? Y will be 100 degrees. Why? For both of these answers, you're going to say vertically opposite. OPP means opposite. Can you see it there what I'm writing? Opposite angles are equal. Then let's do the last one. I'm going to do it right here. To save paper, we need to save paper. Okay, so about that, I hope you can see. So number 4, the last one we do, angles about. Is it about or around? Or around, doesn't matter. Angles around a point. Equals to how much? 360. So we remember we said a revolution. Hey, this thing is keeping on moving. I hope you can see. Are you all fine? Are you all seeing what I'm doing there? So angles around the point, we know they must give us how much? 360. When we add everything around a certain point, it must be equal to how much? 360. So let's say we've got angles like that. They give you that this one is a right angle. They give you that this one is maybe 120. And they say find the missing angle there. What are you going to do? We know that all these angles, when you add them up together, they must give you how much? 360. See, so what are you going to do? You're going to say, okay, this angle is how much? It's 90 degrees. Plus this angle is how much? 120. Plus That's the one that we don't know. When we add all these angles, can you see I'm adding all of them? I must get how much? 360. So I'm going to do what? I'm going to add these two angles together. So you can do it right there quickly. If you are lazy to use your brain. Yeah, no, I knew this one. 210 plus 360. We're looking for the value of this angle. It looks like it's gonna be an obtuse angle, but I just drew. So this drawing is not according to scale, but let's find the actual value of the angle. What are you gonna do? Take this one to the other side. So it's gonna be x equals to 360. Remember, when you're transposing a value across an equal sign, it changes sign. We call this actually what additive inverse, where you actually are subtracting both sides by this value so that x becomes alone. But we just take it like shortcut, and then we say you take that one to the other side. But you're actually subtracting both sides by what? By 210. And then this side, if you subtract both sides by 210, you get 150. Yes, it's an obtuse angle. Can you see? What will be the reason? The reason will be right there. Angles around a point equals to 360. Angles about a point or angles around a point. Yeah, it's just English there. It doesn't really matter. Then there you go. So those are the 4 rules of straight lines. So if we use a question, you have to use one of those things. So I think I'm going to do immediate video on doing the questions because of I don't want to make these things to be too long that it makes you sleepy now. So I'm going to make a video. This is part 1, and then immediately I'm going to make part 2 of it where we're answering questions. So, but as you see, I'm trying to make a simple question on each of them so that you can be able to know the rule and know how to apply the rule. So let's do parallel lines now. Parallel. Is it parallel or parallel? Yeah, it's parallel. So parallel lines are, what are parallel lines? Boo, 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 boo. Parallel lines are lines that are the same distance apart from each other. So the distance there and the distance there should be the same. You must use a ruler. You must use a ruler. So they are in same distance apart from each other. And it's actually very important when you're doing analytical geometry, grade 10, grade 11, grade 12, we actually use parallel lines a lot because of what do we know about parallel lines is that they've got the same gradient, but that is not important for now. So suppose we have a transversal, they call it a transversal line, this one. Let's see the spelling. Trans what? Transversal. Yeah, transversal line is the line that intersects the parallel lines. So suppose that we have a transversal line there. Now these two lines, they have a relationship. We can actually use the rules of parallel lines to calculate an angle at any given point there. So how many rules of parallel lines do we have? We have 3. So there are 3, unless I'm lost. But obviously, if there are more, just tell us, inform us. We'll make a plan. I'll put it here. So the first one is what? Corresponding angles. Corresponding angles. What do we know about corresponding? So I'm gonna just write it like this. If you see CORR, meaning corresponding angles are equal. So let's say, can I draw it here? We've got a parallel line. How do we see parallel lines? By the arrows. This angle there and that angle there are actually the same. So they are corresponding. They are exactly in the same position on the lines. This one is above the line. Can you see? That one is above the line. So they must be in the same position. These two angles are exactly the same. If this is 90, this is 90. If this is 50, this is 50. They are the same. So which other lines are parallel, corresponding? Sorry, these two. As long as you can identify two angles that are exactly on the same position, then you have identified a corresponding angle. So those two angles are also equal. They are the same. I'm going to use this. Let's see. So that I don't draw. These two angles. It's not working. Okay, it's working. These two angle and that angle, they are also the same. Can you see that they are on the same position? So if this is 100 degrees, this angle, automatically you're going to say, because these two angles are corresponding, they are 100 is 100 degrees, 100 degrees. This one there, can I just make it like this and then? Can you see? They are corresponding, they're in the same position. So you're going to say your reason will be corresponding angles are equal, or write it full in a sentence. So let me give an example, quick example. So let's say this is line AD, this is line CD. Okay, then let's say this is 120 degrees, and they say find the value of y. The value of y will be the value of that angle there. Can you identify, first you see that these two, they're actually corresponding, they're on the same position on the lines, they are above the line on the left. Can you see? So you're gonna say, okay, y equals to 120 degrees. If this is 120, automatically that one becomes 120 degrees. Then your reason will be corresponding angles are equal. Because, why are we using this rule? Because AB is parallel to CD. So we are only using these rules only when we are dealing with parallel lines. So it's very important that you indicate in your reason that the reason why you use this rule is because of your identified parallel lines. And how do you identify parallel lines? By the arrows. So it's actually wrong for you to use this rule if you don't see parallel lines. If the arrows were not there, you wouldn't and you shouldn't and you mustn't, you must not use the rule. You only use the rule once you identify the arrows. Let's go to number 2. Number 2. What is number 2? Who knows? Actually, they call it what? The fun. Yeah, so it's 3. It cannot be more than 3 because of, they said, these angles, they form actually the fun. So we are on F, the F word. You're not supposed to use the F word. Yeah, we are on U now. Let's do U. Let's see. What is U? U is for U. Co-interior. Co-interior angles add up to how much? 180. So that is the U, I suppose. So can you see? The word interior means what? Inside. If you talk about the interior of the car, interior of a BMW, interior of a Toyota, interior of a Quiddy, yeah. All this, when someone says interior, they're talking about the inside of a car, inside of a car, inside of a car. If someone talks about the interior of the house, we're talking about the inside. So I'm just doing that to push an idea, like we are dealing with two angles that are inside. Obviously, the two angles cannot be the same, but they have to be inside. Inside, can you see? If they are not inside, you cannot use this rule. So let me show you what I mean by that. Let's say we have parallel lines. We see by the arrows this angle and that angle. Can you see that they form that U shape there? So they're inside. So when we add these two angles together, they must give us how much? 180 degrees. Yes. So when we add them up, we need to get 180 degrees. Same applies on the other side. That angle there and that angle there. When we add them up, we must get how much? 180 degrees when we add them up together. So this rule is called co-interior. Once you identify an angle that is given inside, and you are required to calculate an angle that is inside also, then you need to know that you are going to use this rule. Let me give an example quickly. Let's say this is 100 degrees. Yeah, I've been using 100 degrees so many times. Yeah. For argument's sake, if you know the principles, you understand the principle, you can answer any question. You need to know the principles. So obviously parallel lines, A, B, and what? C, D. Okay, so what are we going to do here? The question will say, find the value of the unknown variable. What is the unknown variable? Is x. You want to know how much is this angle. So obviously they're not corresponding. If they were corresponding, this one would be here and there. This one is not corresponding. So what's happening? Okay, I hope I was not too loud. If it's not corresponding, they are both inside. So what are we going to say? We're going to say, according to coincident angles, angle X and angle 100 degrees must give us how much? 180 degrees. Yes. Therefore, if you're looking for this one, what are we going to do? We're going to subtract both sides by minus. We're going to subtract by 100, not by minus 100. So we're going to subtract 100 on both sides. Or you can say we transpose. So 180 minus 100 degrees. So we actually subtract the given angle to the total number. When we add these two, they must give us 180. So if you subtract this one, what is remaining will be the other angle. So 180 minus 100 is actually how much? 80 degrees. So this angle there is actually 80 degrees. So that when we add them up together, we get how much? 180. We need to get 180 all the time. If you add them up together and you don't get 180, you know that you did something wrong in your calculation. So the reason for this will be co-interior. If you write it like this, theta angles equals to 180 degrees. Why are we using this rule? Because AB is parallel to CD. The only reason why we're using this rule is because of those two lines are parallel. And how do you see? You see by the arrows. Okay, we do the last one here, and then we're going to go straight to questions. We're going to do questions. Okay. Voila. Can you see? Can you see? Can you see? Can you see? Yes. Okay. So where are we now? We're doing the last one, the N. Remember, we're doing fun. So the N is called the alternating angles. What do you know about alternating angles? They are equal. Alternating angles are equal. And fun, let me show you. Fun is actually N. N looks like what? If we turn it, looks like a Z. Can you see? So I prefer to use a Z. This angle there and that angle there are the same, are equal. Can you see? Very important. This one is on the left hand side, inside this, and that one is there. So these two angles are exactly the same. So let me give you an example there using parallel lines. Let's say we have parallel lines. Once you identify a Z shape, can you see? That angle and that angle will be the same. And also, let me use this one. Okay, let me use a different symbol. That one and that one are the same. So they alternate, can you see? One is on the other side, left hand side, at the bottom, right hand side at the top. Can you see? Please, you need to notice them. You need to be able to identify this. So parallel lines, obviously. If this is not there, we cannot use these two rules. So let me show you. Okay, parallel lines. Let me put them here. A, B, C, D. So let's say this is 70 degrees and they want you to find X. Okay. So firstly, are they co-interior? No. If it was co-interior, the X would have been here inside there. It's not inside. This, is it corresponding? If it was corresponding,